Good morning, everybody. Welcome to another Random Code stream. I'm going to continue on with this feature that I've been working on that seems to keep the gift that keeps on giving, I guess. This is a list of all the stuff I still want to do, and I may decide to break some of these off into separate tasks, but I don't know. I feel like these are all related to the work I'm doing, so I may keep doing this. May keep doing all this with this feature. We'll see. So to give context a little bit here, this is a source generator project that automatically adds a deconstruct method, currently as an extension method, to a type that doesn't have it, so that you can automatically do deconstruction on that type. If you look at like these integration tests here, you can see that this one exists, but it doesn't have a match for all three of these. And so what you can do is it will generate a way to, and it's hard to do this here because you can't see the actual call, but it does work, and you can actually do deconstruction that way. So what I've been doing in this feature is actually updating the generators so it uses for attribute with metadata name. Where is that? There it is, which is the right way to do it. Highly, highly preferable that you do it this way. Okay, so let me get some music going here. Do this for about an hour this morning, and before I have to hit the day job. Oh, there was one thing that where is that? Is that in? Oh, I'm in the wrong project. That's why I couldn't find it. Here. Yeah, I was struggling with this last time. I was like looking at the property, the type of the first parameter to see if it had is this, which really wasn't the this that I was looking for. And long story short, I stumbled across that the symbol actually has is extension method on it. So that made things a lot easier, because then I could just look at the name. Does it return void? Does it have more than one parameter? And does the ref count? We got to come back here and fix this too, because there's an issue with the types not matching, but we'll get back to that later. Okay, so the first thing I think I'm going to work on is this internal thing. So what that is about is here, that's getting all these accessible properties. And so we're trying to find on a type symbol all the properties that aren't indexers have a getter method that is either public or internal. Okay, and then we just return those accessible properties. The thing is, if those properties are internal, or the types of the properties are internal, or the type itself that we're trying to target is internal, then the resulting extension class that we make here should also be internal. There's no reason to have it be public, because you couldn't call it, because you wouldn't have access to them unless the assembly has decided to do an internals visible to, and that's the choice of the assembly that's using this generator. So we're just going to mark them as internal. So let's do that. And the place we want to do that, I think, might be type symbol model. Maybe, maybe not. It might be, or actually building the thing. Yeah, because here we create the deconstruct method. Here's where we declare the class. And so we just need to say var is deconstruction internal, which is equal to the type I don't think we capture that on the type. We're going to have to do that. What did I do in rocks, by the way? Okay, so yeah, that's one thing about records that kind of sucks, is as soon as you get away from, you need to do any kind of work, you have to start doing stuff yourself, which isn't a big deal. It just, So, because now I have to break out all the properties myself. I have to... I also don't know why I didn't make that sealed. I usually seal everything by default. Okay. So we need to know if the properties... And so we don't have that yet. Okay, we don't... I've got the wrong thing. Type.declared. Oh, it's just accessibility. Okay. And then the accessible properties are property symbol models. And so we want accessibility, and then we want accessibility type accessibility. And then this will all shake out because we're going to run into problems here like here. So we need the nope. Type declared accessibility. Those are enums, so those will translate correctly. They can work as, when you make immutable models with source generators, you definitely don't want to capture things like semantic model stuff, but if they're enums, they're just values, so that's no problem. Okay, so we're capturing the type, which is fine, and then when we do get accessible properties, what we need is also the accessibility of the property type, and then that. That's kind of big. Okay, so we got all this now. So now we need to say types. The type's accessibility is equal to internal, or type accessible properties any, where its accessibility is internal, or the type accessibility is internal. There. And so then we can say here internal public. And then we'll do the same thing down here. Actually, we could do that. If any of that is true, we'll say it's internal. Otherwise, it's public. And so then you can make it slightly more readable there. Now, this shouldn't have broken anything in our tests. And one failed. Interesting. Oh, yeah. Well, there you go. So this was actually doing the wrong thing, and now we're doing the right thing. So let's actually add some more... Yeah, we're actually getting more tests. That's fine. I'll sort this out into multiple test classes if I need to. With internal... with properties, with property using internal type. So in this case, what we're going to do is we're going to have this be public, but we're going to have an internal class internal type. And so that's what we're going to put there. And so this should be internal value, which doesn't care. There. I believe that's what it should do. Let's see. Nope. Mismatch between number of diagnostics. Ah, that's just a compiler bug. Yeah, you can't even do that. So that actually means our check here during the builder, we don't even care about the type. So we can go back to our property symbol model, and we just have to look at the accessibility here. Because you can't make a property public if the type that you're targeting is internal. So that makes sense. And so that means then, yeah, we don't need this. There. Now, ironically, what you can do is you can have an internal class X public string stuff. And that's just a nullability thing. And that's fine. You can do that. So, but you can't do the other thing. Okay. But what we can do is say generate with internal type. Like in this one, we were doing with internal properties. This one, we're just going to... We can just copy all this now again. And we want to reverse this. We want to say this is internal and this is public. Oh, we probably have a... There, cool. So now we've got both cases. And now all the tests should pass. Mm-hmm. Actually, that's not true. The reason I just realized this, it doesn't matter if this is internal, because a deconstruct doesn't deconstruct to a specific target. You can deconstruct to just variables. They don't have to be of the same type. So that's actually wrong. All we really care about is accessibility, is if the type is accessible. And so that means on our property, we didn't even need this. That was fine as is. Which means we got a bug somewhere because we don't need to pass that in, but that's okay. This wasn't all for naught, because we do want to make sure that if the type is inaccessible, then, like when you look at this test, you have to be able to call this. And so if you can't even see this, then that's a problem. And if one of the properties had a type that was internal, this would have been internal. Wait a minute. I keep going back on something here. Yeah, that actually doesn't make sense now that I think about it. If this is internal, that you have to make sure that that type if the property is internal, then this is a little tricky. I agree with this test. If the target type is internal, then this all has to be internal, because there's no way that you would be able to call this method on a type you can't see unless internal is visible is there. With a property, it's a little bit different. If the type was internal, then this would have to be internal. But if the type is public and this is internal, well, that doesn't matter. This is still public, so you could make it public. And if you're wondering why I care so much about this, it's because we want to make sure that we only expose as much as we possibly need to. So what's the rule? If the type is internal, we make it internal. If a property is internal and its target type and its property type is internal, because if it's public, we don't care. So we do need these back. Accessibility. Okay. And now that should cause a break here. I wish you would have remembered what I typed before. We want the properties accessibility. declared accessibility, and we want the properties type declared accessibility. And so now that we're building it, we want to say, is the type this, or we want to have a types accessible properties any where its accessibility is equal to internal and its type accessibility is equal to internal. So if the type is internal, we make it internal. Otherwise, if you have at least one property that's declared as being internal and its type is internal, if the type isn't internal, like we have, get rid of this. This would actually end up being public. Because a string is public. You can use it anywhere, and so you can deconstruct it. Using public type. And so now what we want is using internal type. And so now we're back to our internal class, internal type. And so we want to change that. There. Okay, so we have a test here. We have an internal property, but the type is public. So we should have still everything be public. We have a public with an internal where the type is internal. Now everything has to become internal. Because you can't expose this type publicly. And then if we have an internal type, like we do here, this also becomes internal. And they all pass. Good. Good, good, good. There. That's what we want to do. So that checks that off. So matching deconstruct, that's another one. Yeah. Seven, 8. I was listening. The music that I play in the background is music I actually wrote. Some of it would, in fact, I think 3 of the 4 songs was with a friend of mine, Mike Hodnick, and this song that you're hearing right now, I wrote in college. It's a 17-minute long epic progressive metal song, and when Mike and I first started working on songs together, a lot of the songs that we recorded were things that I had written that I just never got around to actually recording. So this was one of them, and I don't know, I was really happy with the way it ended up, because It's got all these different time signature changes in it and stuff, and that's all from growing up listening to Rush and other progressive bands that didn't always do everything like a straight 4/4 or a 3/4. And so there's like 6/4 in it, there's a 7/8, there's like now it's a 12/8, and then it kind of goes all over the place, which I always like because it felt like it kept me on my toes a little bit. But with Rush too, one of the things with bands that do like odd time signatures is to do it in a way where you don't maybe necessarily notice it, like maybe something isn't quite there and it's not with the beat, but you can still kind of follow it. And that's always been important to me. Is some bands that do like polyrhythms and they just, it's almost like they're doing it just for the sake of doing it and to be as complicated as they possibly can be, which is fine. I admire that, but sometimes it goes a little bit over the edge, and it's just not. There always has to be, to me, and this is very subjective, some sense of musicality to it, something that that just my brain can grab onto. But again, that's purely subjective, and everybody's got their preferences. All right, stop talking about music. Although that's fun to talk about music. Let's go to where I want to dive into this here. So one thing I realize is this visit method. This isn't correct. We have to actually look and say, okay, we found an extension method, has all the names, has all of the accessible properties that match the parameter length. But what we are not looking at is what are the types. And when we arguably can't use the names, this is where it's going to get quite interesting to figure this out. I am not going to get into I think with deconstruct methods, I believe a deconstruct method, and I guess I could look this up. Although, did I have them in the documentation? Both cases need void. But all deconstruct methods must have a unique number of out parameters. Yes. So you can overload deconstruct, but you can't have like two deconstruct methods that have 3 out parameters. You can have one that has 3 and another one that has 4. That's okay. So it's not quite the overload mess that you run into with methods in C#. So if we have the same number of outs, now we just have to say, do we have ones that are the same amount of types? And we could get into inheritance scenarios where maybe the deconstruct is exposing a base type, but the property is actually a subtype of that base type, which would be okay if you're assigning it out. This is where I wish this set is assignable to. And get accessible properties is returning a property symbol model, as it should. But that makes it tougher because we want potentially the type. Can you? Yeah, there's no is assignable. You can do it, but then if you get into interfaces and does it gets really kind of messy. And of course, if I do this, I should do it right. But there is another feature I want to add to this, which is to potentially not do this at all unless you really, really want to. And so there is a debate in my head going on saying, do I even do this? Like if you've said, I want to have this type have a deconstruct method made, or I want all the types in my assembly to have deconstruct methods made. If there is a deconstruct method that matches on the type, you know, the problem really becomes with records, because records make one by default. Having, you know, your code, you would know if you made an extension method somewhere else. And is it possible another library would have an extension method that would, you know, that's definitely possible, which is why I do what I do here. But all these are kind of annoying. All these little things that I know we got to do, but they're a little bit annoying. Do I have in rocks an extension method? Not on name type. On type? Oh, I've got inheritance hierarchy. Yeah, I don't have what I'm looking for. I could make it so that it's an exact match. But that kind of bothers me. Because what I would really want to be true to this is, do you have an extension method that's a deconstruct where all the parameter types are assignable in some way, shape, or form? So I look at like my first property that I found, and do I find a type, do I find a parameter in the list that matches, that I could assign that property to that as an out? And if I do, then I take that parameter out of the list and I look at my next property and I say, do I have one? So I could do that right now as just being an equality and say, you know, the symbol's the same. But I would really want it to be like, is it assignable to? So let's kind of work with what we got. The first problem is here. What I could do here is, instead of getting accessible properties, we could get accessible property symbols. And so we just say there. So now we're just getting the property symbols that match this. The type Microsoft code analysis cannot be used as a type parameter T in a generic type. Oh, they're not equatable. Well, that's fine. We can just say it's an immutable array of that. That's fine. Because this serves a very specific purpose. And so we're going to get the properties here. And now what we need to do is say var extension parameters, which is equal to symbol parameters. And so we want to go through each property and see if it's in the parameters. And if it is, we have to remove them from the parameters. And we only do this and so I say for each var accessible property in accessible properties, and we want to say if extension parameters any. Now we need symbol quality compare default equals. What we want to do is we want to take, if the extension parameters type is equal to the accessible property type, if that's true, if there's any of them, singular default. Var parameter is equal to this. So now what we need to say here is if this parameter is not null, that means we found a match. And so now what we want to do is we want to say extension parameters is equal to extension parameters, remove that parameter. So we found one, now take that out. And so then we look at the next property and we'd have another one. So if we get to the point where if extension parameters length is equal to 0, now we found a better match. And I'm going to put a to-do in here. To-do. We really should be looking at assign ability, for lack of a better term. That is the property type assignable to the parameter type? Now, this shouldn't break anything? I'm not sure. Okay, one failed. Let's see why. We didn't create one in this case. No, we do. That's the problem. So in this case, now we're actually finding the types don't match. Why is that? Well, let's see. So what did we find here? We found the thing we're looking for. We get one accessible property. And we have two there, so it should go into here. We get the parameters. And actually, before I move on, yeah, I wish I knew ranges better. I want to say here, sorry, I'm really blanking on what I want to do here. I want to slice the parameters. Slice. Start 1. And then I want to go the length -1. So now we should get 1, and it should be the out. Yes, okay. That's what I wanted. I didn't want to get this parameter. Oh, that's probably why this was failing, because we were having 1 left. So we find 1, we remove it, now we get to 0, and we come back up. Yeah, that was the problem. Cool. Is there a way, internet, to... Actually, I want to grab this one. This is for something. This is for... I don't want to lose that as a reference. So let's get rid of that for now. Is there C# I type symbol is assignable to? Has anybody done this? No, I don't want to do that. Jesus. No. Sorry. Don't want to do that. No, I do not want to do type is assignable to. This guy's always got good stuff. Why am I even getting this? Oh, searching internet. Search engine. Why would you... Ugh. And this is like almost 10 years old at this point. Oh, that's right. There's classify conversion. The latest draft of this PR. Add API classify common conversion. Well, I think I'm... Are you saying that there's something on compilation to do this? Is there? No, there isn't. Because it doesn't exist there. There is no compilation. It's a C# compilation. But it's outdated. Just trying to find one thing in the Roslyn API can be classify common conversion. Classifies a conversion from source to destination according to this compilation's programming language. So what would the... You can't let me see that? I just want to see what that is. There. Thank you. I was like, just let me click on the damn thing. Funny that they do it as a struct, and I mean there is an enum, but it's a struct. Huh, okay. The existence of a conversion does not necessarily imply that the conversion is valid. Vigorous user-defined conversion may exist but may not be valid. I just want to know if I can convert it. Huh. Well, I think this kind of sort of gives me what I want. Is that actually on an extension method? No, it's just... There is a has implicit conversion. Turns true if there is an implicit or widening conversion. You know, I know that this is saying the right thing. It's the technical right terminology. But I look at it as just inheritance. And so implicit conversion. What does that mean? Yeah, I don't care about operators. Possible conversions from one type to another. There's a standard conversion. Standard. Oh, standard. Jesus, would you speak English? Oh my God. Sorry, I want. Just want. I want the layperson's definition of this crap. Implicit conversions. Examples include conversions from smaller to larger integral types, which makes sense, and conversions from derived classes to base classes. So from a derived class to a base class. Does it have an implicit conversion? And yeah, I get what the PR was saying is that you can have user-defined conversions. That's where you have like the implicit and explicit, I forget the operator syntax, but you can basically, I use this in rocks, and it's arguably a little fragile depending upon what you're trying to convert to. You got to be a little careful. I think what we really just care about for the most part are implicit and potentially user-defined conversions. So if you say user-defined, explicit, and implicit conversions. So I think this is where you have, yeah, the implicit operator. That's where it is. And so if I came back to this, God, I went down a rabbit hole with this one, didn't I? So I think we must say from a derived to a base. So now what we have to do is somehow get the compilation where am I when I do where am I? What we really want to do is just force the compilation to be passed into this. Because I don't think you can, from like an assembly symbol, you can get to the containing module. You can't get to the compilation. Yeah, I don't think there's any way from that. So I think we have to say compilation, and then we say private read-only compilation. Oh, that was right. This compilation is equal to that. And so down here now, what we want to say is really what we want to do is this. We want to say compilation classify common conversion, and the from is the accessible property dot type is equal to common conversion is implicit. There. This. So we're trying to go from the accessible to this. And so if we had a base to a derived, that's implicit and that should be fine. Now all we need is a deck of cards. Oh, we got to pass in a compilation now. Of course we do. Are we getting it from somewhere? Yeah, here. So then we can shorten this up a little bit. Actually, what we could do is just pass in the compilation. We don't need this. Because we could say here, compilation assembly. And so then we don't even need to capture it anymore. Perfect. And so then actually, okay, that took care of what I was looking for, right? Because now we could just put this in here. No, stop it. I gotta stop soon. Get to work. Okay, does this even build? Okay, cool. Does this test? And it does, because if I think I look at this, that matches. Now we want to be a little bit more cute. And implicit conversion exists. We don't care about that. We want to have public class base type, public class derived type. And we want to say there's an extension method out there that exists where it's the base type. But we are the derived type. This should still work, except the assignment here is completely wrong. Because now we're saying we want self.derived type. And so what we're saying is here, this should not create it because there is an implicit conversion that would exist for this. And this one, yes, there is an, so this one, that's why that one isn't created. This one shouldn't create one either. Oops. And it does. So accessible properties type is the derived type. This should be what is this? Ah, crap. I want to get a breakpoint right on this. There we go. There is no implicit. There's nothing. So and this, I bet. Yeah, they're not equal. They're not directly equal. Do I have them just the wrong way around? Oh, I just realized what I did wrong. It would help if I actually derived the damn thing. Now... Nope, nope, nope. We're all... Oh, come on. Well, does it work now? Nope, it still doesn't work. Damn it. It's not what I want. Okay, stop there, please. So this should, because you see it's is implicit is true. Okay. So that should come out as that. So we should remove that. Why did that go through again? Okay, now I'm convinced that, well, mostly convinced, that this should have we have one extension parameter. We have one property. Do we find one that matches? And we do. So we remove that, we go down to 0. Now we add excluded types, which is test. Okay. Why are we coming back to this again? Test does not contain a definition for... Oh, I was wondering, did I have my code wrong here? Jeez. Yep. There we go. There we go. And now they all pass. But now we're going to flip it. Does not exist. And so we're going to say this is a base type, but this is a derived type. And so we're just going to do this. We're just going to say new derived type, which is odd. Why would you do this? But we should at least not get this to fail because it's going to say we actually created source. Come on. Just show me the... Yes, we do create source now. And what we should probably be creating is a test extension where the out is a base type, except we have to globalize the whole thing. Okay. Hey, I mean, this would be weird. Why would you do this? But we're just trying to be defensive. So now we can say that could be assigned, and that would be what's generated, right? Bingo. Bingo, bingo, bingo. That's exactly what I wanted. Nice. And so now we can take, where is that compilation? That's what we want. I like that. That's a good way to end the stream. Existing deconstruct methods are now found correctly. Perfect. Perfect. All right, so we got two things done, which is good. I think in the next stream, what I'm going to do is this one, and then we'll see if we can get that one done. So with that, I think the next time I'm going to do a coding stream, maybe tomorrow morning or Saturday morning. I'll see. But I do want to get this moved. I might do the docs off camera and just update those myself, because at this point I kind of got the feeling that the docs and what this does, except maybe this would affect the docs, but at least I can make some work on it. And I've been able to make some progress on my upcoming presentations for a user group and a conference, so still need to do more work on that, but at least I got progress there. So I want to thank you for watching. If you're new to the channel and you haven't subscribed yet, please subscribe. I would greatly appreciate it. And with that, I am done with the stream. Thank you all for watching. Take care, and I hope to see you in the future.